Okay. uh, Something on technical terms also, the CBCT protocol parameters. Parameters by definition is a set of exposure parameters, KV, mass, field of view, to produce images of optimal quality while minimizing the radiation. Of course, this is based on the needs. How much size you want, without any causing any radiation burden to the patient. The standard protocols are often pre-programmed in the CBCT, of course, because it's all at the end computerized. Some of the machines are controlled from the machine itself, others are controlled from the computer, depends on the setup of the machine. Parameters may be modified by the radiologists, usually the scanning volume, which is most important, field of view, if it is allowed to be controlled, the voxel size, that is resolution. By the way, higher resolutions means more exposure, increasing the exposure, either the KV or the mass, milliampere second. The number of basic projections, basic projections, and of course the exposure time. Exposure time is calculated according to the parameters or the exposure parameters that are preset in the radiograph. Okay, let's discuss the advantages of cone beam CT over the computerized axial tomography. I think by now, from what has been said earlier, we can have an idea about what are the advantages and the disadvantages of these. Okay, first of all is the cone beam collimation. Cone beam collimation, since we can control the field of view to very small field of view, which is in the CAT scanners, the radiologist cannot reduce the field of view to the extent that we can in the CBCT. I mean, in the CAT scanners, you cannot reduce your field of view to the same of a periapical film, 3 by 4 by 4 centimeters. So, collimation, of course, naturally, as we said, will reduce the radiation dose, reducing the size of the irradiated area by the collimation of the beam to the area of interest. Most cone beam CT machines can be adjusted to scan small areas. Of course, this is being advanced more and more for specific diagnostic tasks, and this is important. It is always the size of the beam that is being radiographed is based on what you need. Okay. CBCT can capture small volumes of data, like 40 millimeters, 4 centimeters height, 4 centimeters diameter volume of data, which is similar to the overall height and width of a periapical radiograph, which is very nice. Actually, you will get a 3D radiograph. Suppose you're extracting a lower 8, you will get a 3D radiograph the same size of a periapical film, which is just magnificent actually. When it comes to image accuracy, the 3D block of voxels determines the resolution of images. We talked about the voxels. In the CAT scanners, the voxels are anisotropic. Anisotropic, it means that it is rectangular cubes where the longest dimension of the voxel is the axial slice thickness and determined by the slice pitch, a function of the gantry movement, how much it moves. While in the CAT voxels can be as small as 0.6. This is the smallest that you can go in the CAT scanner, but their depth is usually in order 1 to 2 millimeters, which is thick. CBCT machines provide voxel resolutions that are isotropic. They are equal in the 3 dimensions. What does this mean? It means you can go to sub-millimetric resolutions, exceeding the highest grade of a multi-slice CT. See the difference? Ranging from 0.4 to as low as 0.1 125 millimeters, like in acutoma. So actually this is very good, because as I said earlier, suppose you have in the 1 thickness millimeter, there is a lesion. Now if you're going for a CAT scanner, if this lesion is hidden in this 1 millimeter, you will bypass it when you navigate. But if you go in a thickness of 0.4 or even 0.1 or even 0.2, then you will not miss anything. Then the resolution is higher. Current units are capable of producing between approximately 4,000 and 16,000 shades of gray. By the way, our eyes can only recognize 56 shades of gray. So you can imagine the huge amount of resolution that you can go through. Scan time in the CBCT acquires all the bases or the basic images in a single scan, single rotation, and the scan time, as we said, varies according to what you have chosen of the exposure parameters between 10 to 40 seconds. Of course, if you reduce the scanning times, the motion artifacts due to subject movement will be reduced. All of us have done chest x-rays. The radiologist, the first thing he asks us that stop breathing. Stopping breathing reduces actually the movement. The more you move during the x-ray, the more is the unsharp of the image, which is called motion unsharpness. If the exposure time is reduced, then the chances of motion unsharpness reduces because of the short exposure times. Dose reduction. Now let's talk about the doses of the CBCT. Effective dose of radiation average ranges between 29 to 50 microsievert in the CBCT machines. Depends on your exposure parameters. So it is a range between between 30 and 50 microsieverts. CBCT doses is significantly reduced by 98% compared with the CAT scanners, which means a huge reduction in the amount of radiation. It depends, of course, on how much you are exposing the patient. Of course, if you're going to a full craniofacial view, 20 by 20 centimeters, the dose is higher. But if you're going to collimate your dose, that is, you're going to reduce your field of view, then the dose ranges between 13 to 100 microsievert, or 4 to 15 times of that of a single panoramic radiograph. Panoramic radiographs, the maximum you can go for 11 microsieverts. So it is 2.9345, depends on your machine. This means if you are going to do one CBCT for your patient, then minimum you're going to expose your patient to 5 OPGs at the same time in terms of dose. So please make sure before you go you refer your patient for a CBCT, calculate the amount of dose. If you want larger views, then expect that you are exposing your patient to 15 OPGs in a single shot in terms of dose. Okay, so this is an important thing that should be taken care of. However, this is for the CAT scanners, for instance. See the fan-shaped average range for the mandible. See the huge amount, around 1,300 to 3,000 microsieverts for the mandible. For the maxilla, it is less because the amount of bone is thinner. See the amount, compare between these numbers and these numbers. So there is a huge amount of dose reduction between the CAT scanners, axial scanners, and the cone beam scanners. However, this is not an excuse to unnecessarily expose your patients to radiation, because it's X-ray on the end. We have to consider the hazardous radiation doses of the patient. See, this is effective dose estimates for common dental radiographs. 4 posterior bite wings using sensors around 5 microsievert. Panoramic radiographs, maximum you can go for 24, between 3 to 24, depends on the size. Some panoramics you can get half of the jaw, okay, or only the TM joints, or only the anterior region, or you can go for bite wings, upper and lower are the same. So it depends on what you want, but a maximum you can go for around 30. Even some machines can go to 30 microsieverts. Ceph, one ceph is 5.1 to 5.6. Full mouth X-rays around it's more than a 1 OPG. And this is interesting. If you are satisfied with OPG, you can take 1 OPG for the whole condition, but you have to sacrifice the resolution. Periapical films have always better resolution.